Tuesday, we were in 7.4, correct?
Yeah.
What did we do on Tuesday?
We did the thing with zero.
Solving polynomial equations in factored form.
Solving polynomial equations in factored form. So, what we saw on Tuesday were equations that look like this. Whoa, that was terrible.
When was that paper due on Tuesday?
Yesterday?
I think yesterday.
Okay, that's what I thought.
We saw equations that looked similar to that, correct?
Yeah.
How did we handle those?
You would make sure you had 2.
2x.
And then you take them down and equal them 0.
Yep. What do y'all remember the property that's called?
No.
What? The zero product property. You guys remember that ring a bell from Tuesday?
Yeah.
Zero product property. If I have two factors being multiplied together, this factor, and they're equal 0, one of those must be 0, right? So that's why I took each one, set it equal to 0, solve for x. So x equals 0 here, and x equals -3. So 0 and -3 were my two solutions or roots, correct?
Yes.
So you are already given the equations in factored form. Today they're not going to be in factored form. We're going to have to factor them ourselves. And we're going to use what we call a GCF. Does anyone know what GCF stands for? Greatest common factor. So I'm going to be pulling out a greatest common factor and then solving my equations. So let's get into factoring polynomials using the GCF. To solve a polynomial equation using the zero product property, you may need to factor the polynomial first, or write it as a product of other polynomials. That's what factoring means. Look for the greatest common factor, like I said, we call it GCF, of the terms of the polynomial. This is a monomial that divides evenly into each term. So we're going to factor out first, and then we're going to be able to solve our equation. Any confusion on what I'm meaning by any of this that I need to clarify? Say what?
We didn't write this.
You can if you want. You don't necessarily have to. These are your notes. That's just kind of like an introduction to what we're going to be doing. No confusion that I need to clear up. Can I go ahead and move on, or are we still writing? Okay, let's move on. So let's just jump into an example. Example 3, finding the greatest common monomial factor. It says factor out the greatest common monomial factor from 4x to the 4th plus 24x to the 3rd. 4x to the 4th plus 24x to the 3rd. So what I like to do when I'm looking for my GCF, my greatest common factor, I like to look at my coefficients first. So 4 and 24 in this case. I like to see what the biggest number is that those have in common besides 1. So is there a number that goes into both 4 and 24?
Yes.
What is it?
4.
4. Is 4 the biggest number that goes into both of those?
Yes.
Yes, because I want the greatest common factor. The biggest. So I'm going to factor out a 4. Everyone with me? If I have 4x to the 4th, how many x's are written there? 4. So that'd be 4 times x times x times x times x, right? If I have 3 x's, or x to the 3rd, how many x's do I have there? 3. X times x times x. So for my greatest common monomial factor, I need to see how many of each variable they have in common as well. So how many x's do we have in common here? 3. When we're talking about GCF, I always like to say you're only as strong as your weakest player. So we can't have more than 3 in common because this one only has 3 x's, correct? So we're only as strong as this weakest player right here. Does that make sense? So how many x's did we say they have in common? 3. So I'm going to pull out an x to the 3rd. So 4x to the third power is my greatest common monomial factor. I'm not done factoring yet, though. I need to find the other factor. So how I do that? I'm kind of thinking of distributive property in my head. I'm asking myself, what, or 4x to the third times what would give me 4x to the fourth?
Wait, what was the question again?
4x to the third. If I distribute this into the set of parentheses, what do I need here to make this 4x to the fourth? So 4x to the third times what would give me 4x to the fourth? It'd just be 1x, or just x. We got to kind of go back to our exponent rules from the first semester. If I have 4x to the third times x, I multiply the coefficients. So what's 4 times 1? 4. Do we have the same base here? Yep, they both have a base of x. So what do I do with the exponents if we're multiplying? Add them. So 3 plus 1 gives me 4. So if I multiply 4x to the third times x, I get back to my original first term. Does that make sense? That's what I want. Any questions with that? No. Now I'm asking myself, 4x to the third times what would give me 24x to the third? 6. Here'd be my answer. Does everyone see that? You're thinking about distributive property in your head. And I can always check my work. If I want to check to see if this is correct, I can always multiply this through, distribute it through, and I should get back to the original answer. So that'd be 4x to the fourth plus 24x to the third. So I know it checks out. Now, how do I know that I got the correct greatest common monomial factor? Well, is there any other number besides 1 or 6 that goes into 1 or 6? Nope. Do they have any more variables in common? No. If you've taken out everything that they have in common, then you know you've factored out the greatest common monomial factor.
How did we get 6 again?
I asked myself, 4x to the third times what gives me 24x to the third? Does that make sense? So 4 times 6 gives me the 24. And then I have that x to the third with it.
Oh, yeah. Great.
Does that make sense?
Yeah.
Any questions on this first example? We okay?
Yeah.
Okay, let's do another one. Factor out the greatest common monomial factor from 8y squared minus 24y. 8y squared minus 24y. So someone raise your hand if you can tell me what the greatest common factor of the two coefficients are, 8 and 24.
8.
8. 8's the biggest number that's going to go into 8 and 24, correct? So I'm factoring out an 8. David, how many y's do we have in common? 1. So I'm just pulling out 1y. Factoring out 1y. So 8y is what I'm saying is my greatest common monomial factor. Everyone good with that so far? Once again, thinking about distributive property. 8y times what would give me 8y squared? Y. Still thinking about distributive property. 8y times what would give me negative 24y? What is it? Negative 3. Now let's check to see if we got the greatest common monomial factor. Of my coefficients in the parentheses, 1 and negative 3, is there a number besides 1 that goes into both of those? No. Do they have any other variables in common? No. So I know I've pulled out the GCF, right?
Yes.
And then distributing in your head, 8y times y gives me 8y squared. That's good so far. 8y times negative 3 gives me negative 24y. So I know it checks out. Not too bad, right? We're good so far.
Yes.
Any confusion I need to clear up? Can I erase? Let's say I give you... what do I want to give you? Say I give you 4y squared plus 7y. I want you to factor that out. Is there a number besides 1 that goes into 4 and 7? No. So can I factor out a number? No. How many y's do they have in common? 1. So I'm factoring out a y. You can just factor out a variable. You don't always have to have a number in common. Does that make sense? So what would be inside the parentheses?
4y plus 7.
4y plus 7. That would be my answer. I just wanted you to see that you don't always have to have a number that you're factoring out. Does that make sense? Can I erase? What if I give you 2x minus 10? What's the biggest number that goes into 2 and 10? 2. So I'm factoring out a 2. Do they have any variables in common? No. You don't always have to have a variable that factors out either. It can be just a number. It can be just a variable. 2 times what gives me 2x? 2 times what gives me negative 10? Negative 5. There'd be my answer. Does everyone see that? Once again, it can just be a variable. It can be just a variable squared. It could just be a variable cubed. It could be just a number that you factor out. Let's say I give you 7y plus 10. Do I have any numbers besides 1 that go into 7 and 10? No. Do I have any variables in common? Nope. So if I wanted to show this as 2 factors, I could write it as just 1 times 7y plus 10. Does that make sense? The only thing I can factor out is a 1. Any questions there? Okay. Can I move on? Now, let's solve equations, putting together what we learned today and what we learned Tuesday. Okay? Solve 2x squared plus 8x equals 0. So I've got 0 on one side of my equation. Is one side in factored form?
Yes.
It's already factored? No, it's not in factored form. So what do I need to do before I can solve? Factor it using my GCF. So, what's the biggest number that goes into 2 and 8 besides 1? 2, so I can factor out a 2. How many x's do we have in common? 1, so I'm factoring out an x. Everyone with me? 2x times what gives me 2x squared? X. 1x or just x. 2x times what gives me 8x?
4.
Did I factor out the GCF? Yep. 1 and 4 don't have any other numbers besides 1 that go into them. They don't share any more variables, do they? So I've got the greatest common factor. What can I do from there? Yep. I'm using my, what property is it? Zero product property. Since I have 2 factors here being multiplied together, equaling 0, one of them must be 0. So I take each factor, 2x is one of my factors, set it equal to 0. Take my other factor, x plus 4, set it equal to 0. For my first factor, how do I solve that for x? Divide by 2 on both sides. What does x equal? 0. 0 is one of my solutions, one of my roots. Am I moving too fast for anybody? Okay, how do I solve x plus 4 equals 0? Subtract 4 from both sides. So what does x equal?
Negative 4.
Negative 4. Negative 4 is one of my solutions, one of my roots. Any questions there? Does it say to check my solution? No, so do I need to? No. Can you if you want?
Yes.
Yep, how would I check my solution?
Plug in the numbers.
Which numbers and where?
0 and where the x's are.
Do I have to just pick one of my solutions, or do I have to check both of them if it tells me to?
Both, right?
I got to check both of them, right? One at a time. Don't plug them in at the same time. One at a time. I'd plug 0 in, and I'd plug negative 4 in. Which equation do you think I used? Do you think I used my original or my factored form?
Factor form.
Are you sure?
No, original.
Are you sure?
What
No,
was the
it's not-
question?
it's not.
I was not.
When I'm plugging in, do I use my original equation or my factored form
Factor
equation?
form.
Are you sure?
Yes.
Your original.
Are you sure?
I'm sure. Factor form.
Do you think it matters?
No.
It doesn't matter. These
You're trying to confuse me now.
are equivalent. They equal each other. Right? It's just the factored form of my original equation, right? So I can pick whichever equation I want to plug into and plug in my two values. Okay?
Yep.
Any questions there?
Nope.
Can I erase and move to B?
Yes.
We okay with this so far?
Yes.
Oh, that was just one equation.
Yep, we're on letter B now. 6n squared equals 15n. Can someone raise your hand and help me approach this one? How would I approach this one?
You factor out of 1.
From where?
No,
No, you factor out in.
3. Yeah.
No, it is 3. He's right.
Factor out of 3?
Yes.
Where? Which side of the equation?
Both sides.
Both sides?
No, you're
No.
getting your GCF. Would be great.
Well, they're not on the same side of the equation, though.
But you gotta put them on the same side of the equation.
How?
What?
How do I do that?
I don't know.
Subtract what?
Man.
You divide by 6 on.
Divide by 6.
No, you should subtract 6 on both sides.
Okay, let's come to a conclusion as a class.
Well, let's talk about what.
Let's talk it through. 6n squared equals 15n. I'm used to my equations equaling 0, right?
This.
This doesn't equal 0.
You. No, it's not right.
Huh.
3K. I was thinking minus 15
Anyone
on
else?
both sides.
Say what?
I was saying minus like 15 or like minus 6 on both sides.
I mean, we can try that. What do you want to subtract from both sides?
Oh, I don't know. I'm not saying it's right. I was just saying what I thought.
No, let's go along with that. What do you want to subtract, Kylie?
Do 6.
Subtract 6n squared from both sides? Okay. Let's try that.
I don't think it's right.
So on the left-hand side of the equation, I get 0, right? Because the 6n squared is canceled out. And I get negative 6n squared plus 15n, right? Does that look okay? Looks okay to me.
Yeah.
I'd say we're heading in the right direction. Well, now what do I need to do?
You need to get the juicy.
Now I can find the GCF, right? They're on the same side of the equation. So what's the biggest number that goes into negative 6 and 15?
3.
3. How many n's do we have in common? 1. 3n times what gives me negative 6n squared?
Negative 2.
What?
N.
Wait. How do you get negative 2?
Because
3n times what gives me negative 6n squared?
Oh.
Yep.
I was looking at the wrong thing.
3n times what gives me 15n?
5.
5. Did I grab the GCF? Did I get the greatest common factor? Yep. There's no other common factors between 2 and 5. They no longer have any n's in common either, do they? So I got the GCF. Now what do I do?
You do the 0 product property.
0 product property. 3n equals 0. Negative 2n plus 5 equals 0. This one's pretty easy. Divide by 3. What does n equal? 0. Everyone okay with that one?
Yep.
Okay, what's my first step on this next one?
Subtract 5.
So I get negative 2n equals, what's 0 minus 5?
-5.
Negative 5. Now how do I get n by itself? Divide by negative 2. Whoa, that's bad. N would equal positive 5/2. halves. Any questions there?
No.
Not too bad? Remember, to use the zero product property, we want one side of the equation to be in factored polynomial form, the other side to be 0. If one side's not 0, I can't use the zero product property. Okay? Can I erase?
Yeah.
So you guys decided to subtract 6n squared from both sides. I would have subtracted 15n from both sides, but you get the same answer. I would have gotten 6n squared minus 15n equals 0. Factor out of 3n. That'd be 2n minus 5. Set those equal to 0. One of my answers is the same. Both my answers are the same. You could have done it either way. Okay? Any questions? Can I move on? Here's our assignment. Pages 365 through 366. Numbers 25 through 38 all. You're doing all of them.
Jesus.
That's okay. It's like 13, 14 problems. It's not bad.
What is it?
What's today? The 21st?
Yeah.
I'll make this due the 22nd. I could make it due tonight.
Can we
No.
please? I please not.
Not tonight?
No.
Okay, we'll make it due tomorrow night. You're welcome.
Thank you.
You're welcome. You guys are welcome.
I have to.
Any questions before I stop my recording?